All right, this is the second video for section 8.3, and we're going to talk now about hexagons. You'll notice that we have a few formulas here for hexagons. We have an area formula, and we are going to just use this, and so we don't have to really put that in, but basically you get that from taking 3 times the square root of 3 divided by 2, and then it's just simplified to this decimal number. And then distance across the corners. So from corner to corner, our distance is 2 times A. And remember, A is the length of a side. And then, or we can do 0.5 times the distance. It's going to be that, right? So that would come out the same way depending on which way we solved it. The distance across the flats. So from a flat side to a flat side, that's this distance right here. We would have 0.1732 times the length of the side, or if we knew the length of F, we would use A equals 0.577 F. So it just depends on what we're given whenever we're looking at this. In a regular hexagon, all the sides are equal and all the angles are 120. We're only going to work with regular hexagons in this book. In fact, in this chapter and in chapter 9, we'll have hexagons in that chapter also as part of prisms. Okay, so on this we're going to find the missing dimension and the area. Okay, so the missing dimension is A. That's what we're looking for. In this case, we are given 56, and 56 is D, right? The distance across the corners. So from corner to corner is 56 inches. So if we use right, this formula, and our distance is 56, we're going to say 56 equals 2 times A, and we divide by 2 to get A. So A is 28 inches. Right, because our dimensions are in inches. It's a little bit fuzzy there looking at that. And then we're going to find the area. So my area will be 2.598 times A squared, which is 28. And then you can key that into your calculator just like that if you want to. If we do square 28, we get 784. You will find that calculating in these chapters is a really important part of this. You have to be very careful and make sure that you get all your numbers in there. Don't leave out your exponents and calculate carefully. So we get 2,036.8 square inches. And then I'm just rounding this to the 10th place on this. I didn't actually say that anywhere, I guess. Now, what if we were going to find the perimeter? Well, that would be pretty easy, wouldn't it? Because we would just take a hexagon has 6 sides. One side is 28, so we would take 6 times 28 to find the distance around the hexagon, and it would be 168 inches. All right, so that's it for that one. On this one it says, now this is where we start to combine some shapes. I had to pause for a minute. So we combine some shapes here, and we have to first of all just identify, what do I have? Okay, well, I have a hexagon with a square inside. Okay, they only give us one side, so we're just assuming it's a square, and that is an okay way to go. The 8 is across the flats. Okay, and so if we go back and we look at our formulas on this previous slide, then we see that the length of the side is 0.577 times F. Well, this is F, right? That's F. So F is 8 inches, right? That's across the flats on my hexagon. I'm going to plug that into the formula to find A, because if I'm going to find the area of the hexagon, I need to know the length of the side. When I multiply that, I get 4.616. Now, using one formula versus the other formula, and it's actually okay to do that, you can end up with a little bit different answer. And so as far as rounding goes, sometimes, you know, I just keep that in mind that that can happen, so that we can make sure that we're on the right track. Our numbers aren't quite the same, but it's okay, because it's just the fact that these formulas are rounded, and using one versus the other can change it a little bit. All right, let's look at this then. If I'm finding the area of the hexagon, then I'm going to take 2.598 times the side squared. You don't want to round this any more than it was in the first place, right? Because it came from there. And then we get 55.4. Now you can write out more decimal places there if you want, and that's okay. Now the area of the square is pretty simple, right? Area of the square is going to be 6 to the second power, right? 6 times 6 base times height, if you want to look at it that way. And so the area of the square is 36. Now these are both in inches squared, but I'm just going to go ahead and label my final answer. So to get the shaded area, I take the hexagon and subtract the square. So 55.4 minus 36 is 19.4. If we round that to a whole number, it's 19 square inches. And I'm going to go ahead and label both of these too, so you don't think that I'm just slacking off. But it's always good to think of a plan. What is my plan? Okay, I need to find the area of the hexagon, find the area of the square, and then subtract, right? And I did that. Area of the hexagon, area of the square, subtract. All right, let's go on to the next question. And now this is where we're talking about some irregular polygons. This one was just a hexagon and a square, but irregular polygons are combinations of more than one shape, and so they're kind of put together in a different way. So the plan would be divide the shape into simpler, more familiar figures, find the area of each shape, and add those together. And so you just have to basically figure out, okay, what do I have here? And let's see, I'm going to use pink so you can see that better. So we're going to split this into a triangle and a rectangle. And then I simply have to find the area of each. And so on my triangle, I have a height of 24. It's drawn out here. That's perpendicular to the base. My base looks a little wonky here. Let me see. The base of the triangle is the same as the base of the whole picture of the rectangle, which would be 13. So for my triangle, right, the area of my triangle, I'm going to have a base. Let me write this out. My base is 13 inches. And my height is 24. So I can use my normal formula here. 1/2 base times height. So 1/2 times 13 times 24. Half of 24 is 12. So I'm going to take 12 times 13. And I get 156 square inches. And then for the rectangle, base times height, length times width, however you want to say that. Hold on, let me put my triangle there. So I'm going to take 13 times 6, and that is 78 inches squared. And then, of course, I add them. So my total area is 156 and 78. So 234 square inches. All right. So that wasn't too bad. Some of the shapes get a little more difficult than that, but this one wasn't too bad. I'm looking at how many problems I have left here. So this is 9. Okay. So we'll go ahead and do the next one, and then I'll probably stop and start a new video. Okay, so here we go again. We've got this figure, right? It's an irregular polygon. It's got 3 parts. As you can kind of see, it's given us the height for each one of those. And so what I have here are 2 parallelograms, and that would be my top and bottom, right? Wait, let me use the pink here, right? And both of those have a height of 20. So I'm going to say my area is, the base is going to still be 6, and my height is 20, and then that's going to be times 2. So 120 times 2, and that's 240 square feet. And then I've got the rectangle in the middle. And it has a base of 6, a height of 19, and that's 114 square feet. And then, of course, I add those, right? So my total area is 240 and 114, so 354 square feet. All right, so I'm going to stop the video here, and then I will finish on the third video.